In the first two parts, we looked at right triangles. First, we looked at one in which we had an angle, we had a side, and we wanted to know a second side. So we would use something called trig ratios and set up an equation like this: sine 28 degrees equals x over 16. And in the second part, we looked at a different kind of right triangle, and we used something called inverse trig. So this is where we're missing an angle and we have two sides, so we'd come up with something like cosine theta equals 22 over 31 and solve it. So you might be asking yourself, what's next? Let's do it. Let's go ahead now and take a look at our first word problem. We have Taylor attaches a 75-foot long cable to the top of a building. At the ground, she pulls the cable taut and attaches that end of the cable to the ground. If the cable forms a 32-degree angle with the ground, how tall is the building? One thing I always want you to do is, either in your mind or on paper, think about SOHCAHTOA, because we're going to be using either sine, cosine, or tangent. Let's go ahead and draw a diagram. That would be step one in solving this here. So I'm going to do my best diagram here. I'm not the greatest drawer in the world, but it'll work here. So I have this building. I know there's this cable that's attached at the top and then is pulled all the way over here to the ground. And we have the ground would, of course, the building would sit on that. So we have ourselves over here a right triangle. So this allows us now to do this right triangle trig. We're using sine, cosine, or tangent. Some information we know is we know from the cable is 75 feet long from the ground out to the top of the building. We also know this angle right over here is 32 degrees. And now what we need to ask ourselves is, what are we trying to solve? Is it how far is the cable from on the ground from where it is out to the bottom of the building, or is how tall? Well, it's how tall. So this is going to be our x over here. I'm going to put an x right there. So we have ourselves our right triangle. So that'll be step one. Go ahead, make a diagram. Step two is we need to come up with an equation. So thinking about SOHCAHTOA, I have my angle measurement over here. So this is going to be, if I look directly across, that's going to be my opposite. I know across from my right angle, I have the hypotenuse, and then along this bottom here, I'm going to have my adjacent. So this is going to involve opposite, and it's also going to involve hypotenuse. So that's going to be sine. So now we can write our equation. We can write sine 32 degrees equals x over 75. From here, we're going to go ahead and make it so we have a fraction on the left-hand side. And now what we're going to do is we're going to go ahead and we're going to cross multiply. So 1 times x is x, and then 75 times sine 32 is 75 times sine 32 degrees. So go ahead, grab your calculator right now, and I want you to enter in 75 times sine 32. Remember, you don't need to put a degree symbol. The calculator already knows that. So when you do that, if you've done it correctly, you should get x is going to be about 39.74. And then in this kind of a situation, we definitely need our units. So we're talking about feet, so we're going to say feet. As always, if you like what you see, please like, comment, or subscribe. Thank you, and back to part two. All right, let's go ahead and head to our second word problem. We have Travis is standing 40 meters away from a flagpole that is 20 meters tall. If his eyes are 1.7 meters above the ground, what is his angle of sight to the top of the flagpole? So let's go ahead and let's draw a drawing of what this might look like here. So that's flat ground right there. It may not look like it, but trust me, it is. We've got our flagpole, and let's go ahead and put a flag on there of some sort. So there's our flagpole. We've got Travis standing over here. I'm going to go ahead and draw my best stick figure that I can here. Here's Travis standing here. Now, none of this is really to scale, but I think you get the idea of what this might look like here. So Travis is looking straight up there, and let's see here. We don't really know that distance. However, if I look directly across from his eyes here, I can actually form a right triangle, which is key because sine, cosine, and tangent does not work without a right triangle. We're trying to figure out this angle over here. That's his line of sight. So here's what we know. He's 40 meters away from a flagpole. So we know that this distance along the bottom is 40 meters. We know the distance from the top of the flagpole all the way down here to the bottom is going to be 20 meters. And then finally, we know that the distance from his eyeballs to the ground, here to here, is 1.7 meters. Once again, this is definitely not drawn to scale, but let's go ahead and just take a look at this right triangle right here. I'm going to redraw it over here so it's a little bit easier to see. We know the bottom of it is 40 meters. We're trying to figure out this angle. Now we need one more side, and it's going to be the side right here. It's not exactly the height of the flagpole, because we know the entire flagpole is 20 meters, but his eyes are 1.7 meters off the ground. So this is going to end up being 20 minus 1.7, which is 18.3. So at this time, what we're going to do is we're going to ask ourselves, which of these three ratios is it? Is it sine, cosine, or tangent? So if I look directly across, I get opposite. If I look across from my right angle, I get my hypotenuse, and this is my adjacent. So clearly we have information about opposite and adjacent, so that's going to be tangent. So we are going to say tangent of some mystery angle is equal to 18.3 over 40. We learned last video that in order to solve this kind of problem, we need to use something called inverse tan. So we're going to use tan -1 of both sides to figure this out. So that's inverse tan. And we learned that tan and tan -1 cancel each other out, so we're left with theta. And on the right side, we have tan -1, or inverse tan, of 18.3 divided by 40. Now you can go ahead and convert this into some sort of a decimal. It'll be a little bit less than 0.5, but there's no need. Grab your calculator, hit the second button, then hit tan. That'll give you inverse tan. And then hit 18.3 and then divided by 40. So if you've done that correctly, you will get about 24.58 degrees. So that's it. You've now learned how to master word problems. That wasn't so bad, was it?